All right, last lesson we are going to talk about some derivatives of other trig functions and then just apply our derivative rules in other situations to solve some tricky problems. So the derivative of tangent. We don't know what the derivative of tangent is, but we do know that we can write sine over cosine and take the derivative using the quotient rule. So let's go ahead and do that. Derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom square. And I'm going to go ahead and rewrite this as cos squared x plus sine squared x. We got a minus a negative, all over cos squared x. Now I can simplify this as cosine squared plus the sine squared is the unit circle Pythagorean theorem. A squared plus b squared equals c squared. In this case, c squared is the hypotenuse of a unit circle triangle. Always length is 1. So I have 1 over cosine squared. And I actually can rewrite this as secant squared x. And we say that that is the derivative of tangent. The tangent slope generator is secant squared x. Now we could go through that entire process as well with cotangent, but you could just take my word for it that you would get negative cosecant squared x. Okay, so these functions, when plugging in, now understand, when we're squaring a trig function, I would do, the cosecant of the value first, square it second, and then apply the negative sign. So it's telling me that all of cotangents tangents are going to be negative, and that ends up being the case. Okay, and then all of tangents are going to be positive because we have 1 over cosine squared. Those cosine values, positive or negative squared, become positive. Let's look at some others. You can look at secant and cosecant to wrap things up. I can start by rewriting secant as 1 over cosine. And instead of writing it as 1 over cosine or secant, watch what I'm going to do. I'm going to rewrite this as cos x to the negative first. I'm going to use the chain rule to take this derivative. Let's see how that works. So the outside is the stuff to the negative first power, so I'd have negative 1 to the negative second. Leave the inside alone. Times the derivative of the inside would be negative sine of x. So this is the derivative. This is the tangent slope generator. That can be simplified to sine x over cos squared x. I'm going to go ahead and rewrite it as 1 over cos x times sine x over cos x. Why I'm going to do that? Because typically we say the tangent slope generator of secant is secant x tangent x. Secant x times tangent x. And similarly, the derivative of cosecant is negative cosecant x cotangent x. Okay, now make sure we're comfortable with, and typically with secants or cosecants, the derivatives using the chain rule can sometimes be tricky. Let me just give you an example that is a composition of 3 functions. All right. Okay, so we have, after I rewrite this, secant of 4x quantity squared. We have an outermost piece, which is the stuff being squared, a middle piece, which is the secant of stuff, and an inner piece, which is a 4x. Okay. Now, I'm going to pay special attention to the middle piece. Its derivative, if I'm going to take the derivative of these pieces, is secant tangent, but we would write it secant of tangent of. It's very important not to just write it next to each other or to write secant x tangent x. It's the secant of times the tangent of whatever we have. Okay, so this derivative actually ends up looking like the following. 2 secant of tangent of, and 4. You can multiply the 4 by this 2, gives it an 8. What is on the inside? This would be the secant of 4x. This is to the first power. This is 4x and 4x. The 4x would go in both locations, okay? So be wary of that when taking derivatives of trig functions like tangent, secant, cotangent, okay? But these derivatives of these 4, as well as sine and cosine, which you already have memorized, these others need to be memorized. Duh. Okay, lots of different ways to memorize them, remembering the C's, understanding these are similar to each other, these are similar to each other. They need to be committed to memory. So let's move on to another type of problem. Here, different types of problems applying our derivative rules, okay? They're called table problems. And we are applying our rules. Yeah. Okay. So you're asked to find the derivative of f plus g at x equals 2. And most students can do this correctly. The first try, they say, oh, the derivative of f is just f prime, and then the derivative of g is g prime, and I got this, and then I plug in 2, so I need to find f prime of 2 plus g prime of 2. And then we use this table for our information. A bunch of x values, f prime, g prime values. F prime of 2 is 7. G prime of 2 is -4. And I get 3. And they are correct. So very well done. But then they go to this next problem and they're like, oh, okay. So just do the same thing here. F prime, g prime. And I plug in 4. And I'm just going to go ahead and stop you now. If you did it this way, you'd be wrong. Completely wrong. Because you got tricked and you fell into the trick, starting from here and then going here. You thought that the derivative of two things that are being multiplied together is just the derivative of the first times the derivative of the second. And we know that's not correct. We must use the product rule. And use our rules. The derivative of f times g we know is the derivative of the first times the second, plus the derivative of the second times the first. Plugging in 4, we can just skip the whole plugging in step. I'll show it one more time, but we'll start skipping it from here. F prime of 4 is pi over 2. G of 4 is -3. G prime of 4 is pi. And f of 4 is 9. Let's go ahead and add these together. This is 9 pi. That's 18 pi over 2. This is -3 pi over 2. You can add those together and get 15 pi over 2. Okay, so we must be careful with these table problems. Okay, and then all we are doing is taking derivatives of different things with f's and g's, et cetera, et cetera. Now we look at this one. We see we have a quotient. Don't fall into the trap and say this derivative is g prime over f prime. Don't also fall into the trap and say that this derivative is f prime g minus g prime f all over g squared. This is wrong as well. Why is this wrong? Because look how they wrote it. They put g on the top and f on the bottom. So you need to adjust your formula, understanding it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, with the bottom being f. Okay, and then you would use your table to plug in the values. Just be careful when doing it. They also might trick you by throwing in a number, before a function. I could have thrown in a 4 here. There's two ways to tackle these. You can either go ahead and bake it in. not bask in, bake in. What do I mean by bake in that number? Well, I'm saying associate that 3 with this f of x and have that be one term and g be another term, and you could use the product rule using that. So let's see what that would look like. The derivative of 3f of x would be 3f prime of x times g, plus the derivative of g is g prime of x times, this would be 3f of x. And then I would go ahead and subtract the derivative of f. The derivative of f is f prime. So again, this whole subtraction of this f, we have to, we can't forget about it. Okay, so this would be the derivative. You could plug in your values here. Or you could leave it out. I could leave the 3 off to the side and just multiply by the derivative of f times g. So you'd have 3 times, f prime g plus g prime f minus, that'd be there, minus f prime. Okay, all up to you. All right, so you have to be ready for those. Don't fall into tricks. But these are easy because the values that you are finding are easy to find, which is why we didn't do it for more than just 2 examples. Okay, you can just look and you can find the values. Sometimes they get harder by giving you graphs. Okay, let's change this to a 2. Let me show you what that means, why this is harder. Okay, let's see. We want to find p prime of 4, and p is f times g. So let's just go ahead and write it out. There's no real tricks here as long as you don't fall into the f prime times g prime trap. You just need to write out its derivatives and then plug in 4. But now the question is, where does this information come from? I have a graph of g and a graph of f. Well, I guess the g of 4 values, if I look at x equals 4, g of 4 would be this y value here, 3. Okay, so I got 3. Look at f of 4 looks to be 7. But where does f prime of 4 and g prime of 4 come into play? How do I find those values? Remember, this is the slope of the tangent to the function at this location. If I look at g right at 4, I can see the slope of the tangent. Because this is a line segment, it can be calculated. Very obvious what g prime of 4 is. It's 0. What about f prime of 4? Well, this line segment has a consistent slope. So the tangent slope would be the exact same as just the slope of a line. You could use rise over run. You could pick 2 points. However you want to do is down 1 over 1. This slope is -1. Meaning that this answer is -3. So you look at slopes of line segments to get those prime values. Okay, now here's another example. I have a 2. I'm going to go ahead and show the leave out technique. To leave out, I would just have 1/2, and then I'd write the derivative f prime g minus g prime f. I'm excluding the x's for brevity over g squared. Okay? Now, the 1/2 being left out will work. Okay? If it was in, it'd have to be baked into a lot of things if you want it to be incorporated everywhere. Sometimes it's nicer to leave this and to rewrite this as 1/2 times f over g, which is why you can have this. Now let's find q prime of 8, so I'd have 1/2 f prime of 8. This line segment here has a slope of 2. G of 8 is 2, right there. G prime of 8, this slope here is negative, looks to be down 1 over 2, -1/2. F of 8 is 6, all over g squared, so that's 2 squared, that's 4. 2 times 2 is 4. This will be plus 3. 4 plus 3 is 7. Divided by 4, divided by 2, gives me 7/8. Okay, that's simple, as long as we are careful. But where things get really tricky and where we have to be careful is the chain rule. Okay, Students usually mess up on these problems with chain rules. Now, it's not with this first one. Hopefully we've established that for this one, the outside would be the f and the inside would be the g of x. If you took the derivatives of the outside, you'd get f prime of, and the derivative of the inside, you get g prime of x, which is why you'd write this as f prime of g of x times g prime of x. Okay, so that's good, but now we need to be able to plug in 1 and evaluate. Now we have to plug in 1 here, but be careful. So this is f prime of g of 1 times g prime of 1. I'm going to move this next example over just so that we can see and we don't make mistakes here. Now, f prime of g of 1. We have to find what g of 1 is first. G of 1 here is 1 is 5. Looks like 5. No, 2, 3, 4. That's 4. Okay. This becomes f prime of 4. Now, g prime of 1, the slope is negative a half, so put that slope down. Slope of the tangent, negative a half. Now, we have to find f prime of 4, not f prime of 1. It's f prime of g of 1, which turns into f prime of 4. F prime of 4 is negative 1. So this would be negative 1 times negative a half, which is positive a half. Okay? So let's make sure we are very, very careful. When we're doing the work there. Okay? But now let's go to something a little bit trickier, which is this guy. Now I'm even going to change it up to make it a little bit easier. And I'm going to put f of x squared instead of the square root. Simple. F of x squared. Okay, maybe it's parentheses around the f of x like that. All right. I need to find the derivative of that when x is 4. Well, most students say the derivative of this is 2f of x. And then they plug in 4, they got 2 times f of 4. F of 4 is 7. They get 2 times 7, 14. Wrong. Wrong, 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 wrong. And this is where the chain rule messes us up. Okay? Let me go back and move that back over. Okay? This function has an outside and an inside. The outside is the squared. The inside excuse me, is the f of x. Notice, if you take the derivatives, you have 2 stuff to the first power, but the derivative of f is f prime, which is why this derivative is 2 times f prime, 2f of x to the first power times f prime of x. Okay? We need this extra f prime. We have to have it. Now if I plug in 4, I can find 2f of 4 times f prime of 4. F of 4 is 7. So 2 times 7 times f prime of 4 is negative 1. So answer is negative 14. Let's do another one. This guy, g of x cubed, okay? Well, why don't we go ahead and just put in that root g of x. That way we're comfortable with it. Okay, what is this derivative, root g of x? Well, the outside is the 1/2 power. The inside is the g of x. Taking the derivative of this, you need the 1/2 stuff to the negative 1/2 times the g prime of x. So crucial, so many students forget it. Do not forget it. These chain rule problems. So I have 1/2 g of x to the negative 1/2 times g prime of x times the derivative of negative 2x plus 3, which is negative 2. Oof. Plug in 4, g of 4 ends up being 3. So it'd be 1 over 2 root 3. I just rewrote this negative 1/2 as 1 over g of 4 to the positive 1/2. Times g prime of 4, which is 0, minus 2, I get negative 2. Okay, because this time this is 0 minus 2. Okay, so chain rule, man, super important. We do the same problems here, just being careful and using a table. Something cubed. Don't forget the times the derivative of the inside. If I want to find it out at 2, it'd be f prime of g of 2 times g prime of 2. G of 2 is 3. This would be f prime of 3 times g prime of 3, g prime of 2. F prime of 3 is 4. G prime of 2 is negative 2. So this is negative 8. Plug in 2, I get g of 2. So 3, this should be a squared. So 3 times g of 2 squared times g prime of 2. G of 2 is 3. 3 squared is 9. Times 3 is 27. G prime of 2 is negative 2. 27 times negative 2 is negative 54. All right. A couple more problems and finish this off. This is a different situation, but very similar to these table problems. It's just understanding your notation and executing the notation the correct way. So the first one, f prime is x squared minus 2x plus 4. G is f of this. What is g prime of 2? Let's first find g prime of x. Well, it is a composition, so please note the composition. It's f of and 2x cubed minus 10. The derivative of f of would be f prime of. The derivative of 2x cubed would be 6x squared. So g prime of x should be written correctly as f prime of 2x cubed minus 10 times 6x squared. If I want to find g prime of 2, let's see what it would be. It would be f prime of 2 cubed is 8 times 2 is 16. 16 minus 10 is 6. And then 6 times 2 squared, that's 24. So it's f prime of 6 times 24. How do I find f prime of 6? Well, here's what f prime is equal to. F prime of 6 is 36 minus 12, which is 24, plus 4, which is 30, 28. So 28 times 24 will be g prime of 2. What is 28 times 24? 672. Okay, next one, same thing. We're given h prime of x. We're told that g is equal to h of 3x. What is g prime of pi over 2? Let's find g prime of x. Go ahead and take the derivative of the outside, multiply by the derivative of the inside, leave the inside alone. Plug in pi over 2, and you get h prime of 3 pi over 2 times 3. H prime is here. What's h prime of 3 pi over 2? Negative 1. That's the sine of 3 pi over 2 times 3, negative 3. Okay. Two more problems. I'm given what f is equal to. I'm told that g exists, but it's not given. I want to find the derivative of f of g of x. So 2 ways to do this. You can either write it out as f of g of x. Now, I'll just do it both. If I did f of g of x, I'm plugging g of x wherever x is. So I would have this as g of x squared minus 3 times g of x. Okay? How did I do that? F of g of x. Plug g of x in for x, so that goes there and there. Okay, now if I took the derivative over here, I would say, okay, that's f prime of g of x times g prime of x. Here, this derivative would be 2g of x times g prime of x, where everybody trips up, minus 3g prime of x. Now, this would be written, you could also write it this way. Now, you could write what f prime is. F prime of x is 2x minus 3. So if I plug in g of x into 2x minus 3, I have 2 times g of x minus 3, all times g prime of x. Notice if I distribute the g prime of x, I get exactly what I had here. So 2 different ways to get this answer. Maybe be comfortable with both, but if you prefer one or over the other, that's totally fine. Now let's write g of f of x. Well, in this situation, its derivative is going to have to be a specific way, this way. So maybe we don't want to be comfortable with both ways, when in this case I need to do it this way. It'd be g prime of f of x. I don't know what g is, so I don't know what g prime is. I'd have to do g prime of f of x is x squared minus 3x. And f prime of x is 2x minus 3. That'd be the correct way to write things. Okay, so all these table problems, all these rules, very, very important to be careful, to understand your rules, to apply the chain rule, especially when tackling these. Okay, good luck out there.